Hello, my name is Monish Saravana Sundari. I'm a 7th grader from Orlando Science Middle High Charter Schools in Orlando, Florida, USA. My project is to see if using ferrofluids for oil spill cleanup will have any effect on ocean acidification. As you may know, ocean acidification is a major result of climate change, which is one of the world's most important problems. This is especially important because ocean acidification can affect so many things. For example, with the current trend and increase in ocean acidification, foraminifera, a species of zooplankton, may go extinct by the end of the century due to increasing pH. This is even more important because nearly every marine animal eats foraminifera or eats an animal which eats it. This makes it especially crucial to the food web and the carbon cycle. In order to conduct the experiment, first add 50 milliliters of salt water to a beaker. Then add varying amounts of ferrofluid. Next, wait 30 minutes, measure the pH of the salt water and record the data. Finally, repeat the previous steps for each trial. The results of the experiment showed that there's practically no change happening in the pH of the salt water. Taking all of that into account, the results evidently show that using ferrofluids for oil spill cleanups will not have any effects on ocean acidification. The pH of the ocean surface has already fallen 0.1 units from 8.2 to 8.1 in just the last 270 years, which is around a 30% increase in acidity. This makes the water more corrosive, which ultimately affects the marine creatures. It can seep through their skeletons and shells, mainly which are made of calcium carbonate, and can make it hard to grow in the first place. One of the main creatures affected by this is coral reefs. The water will corrode pre-existing skeletons while also simultaneously slowing the growth of new ones. This leads to more vulnerability for erosion. And since coral reefs acts as a buffer protecting our coasts from waves, storms, and floods, coastal communities will experience higher property damage, faster erosion, and more losses of lives. Also, two major types of zooplankton, foraminifera and pteropods, build their shells out of calcium carbonate, which is very susceptible to corrosion. The reason we care about such small creatures is that they play a really big role in food webs, as almost all larger life eats zooplankton or other animals that eat zooplankton. The shells of pteropods are already dissolving in the Southern Ocean, where more acidic water from the deep sea rises to the surface. Magnetic nanoparticles are put in the water, to be specific, ones with oleophilic surfactants, so that they bind with the spilled oil. Then the particles and oil could be extracted out from the water using magnets, resulting in the oil being cleaned up. It's mainly more environmentally friendly because one of the main methods of cleaning up oil spills is burning it, which results in a lot of carbon emissions. This worsens ocean acidification. But, as we've seen from this experiment, ferrofluid does not, so it'll definitely be better for the environment. But one of the cons is unknown effects of ferrofluid, as it's a fairly new and emerging technology, and there has not been much research on it yet, so it may hold some unknown effects. Yes, another useful purpose is that ferrofluids can be used to extract viruses from water sources, and knowing the pH won't change can be used to make sure the virus doesn't mutate or get affected in any way in case we want to preserve or study it. That concludes my presentation. I hope you all have a great day. Ocean acidification is a really important topic because just in the last year, Earth's oceans have absorbed enough heat to boil 1.3 billion kettles of water, and it's not slowing down unless we do something about it.